Well, hello everyone, and welcome again to another OpenShift Commons briefing. Today we have Jacob Liberman, who is the author of the OpenShift on OpenStack Reference Architecture, and we've invited him here to tell us a little bit more about it, to walk us through it, and I'm going to let Jacob introduce himself and take it away because there's a lot of content here. We'll have live Q&A at the end. And we will probably be ending in about 40 minutes because Jacob has another commitment. So let's kick it off and get started.
Okay, thank you, Diane. So hi, everyone. My name is Jacob Liberman, and I'm a field product manager at Red Hat. And what that means is that I work with some of our strategic customers and the field, which is our sales and consulting group, to close the feedback loop with engineering and to make sure that we're building things that people want. So today I'm going to talk about a reference architecture that we recently published, OpenShift 3.11 on OpenStack 13. Or if you want to adhere to Red Hat branding standards or Google search the title, it's actually deploying Red Hat OpenShift Container Platform 3.11 on Red Hat OpenStack Platform 13. So, and also just to let you know, these are a few of the programs that my team runs. I won't spend a lot of time on this slide, but basically we run a number of programs connecting the field and customers to engineering, both internal and external. So before I jump into the reference architecture, I have about 18 slides total, and I'm going to try to move pretty quickly. I just want to briefly mention where this thing came from. So this is OpenShift 3.11 on OpenStack 13. Obviously, OpenShift 4 has been released, but most of our customers are still on 3.11. So this document is in the process of being updated for OpenShift 4. We're working on that now. However, this is still very relevant and applicable for the customers who have not yet adopted OpenShift 4. Now, the reference architecture itself, it's just kind of interesting how we developed it. Last year, we had a Hackfest, which is kind of a Red Hat internal event where we brought together engineers from both the OpenShift and OpenStack engineering teams, as well as field experts on OpenShift and OpenStack, and we put them in a room for a week. And we whiteboarded, executed use cases, talked about how customers are actually using these things together in the field. And out of that Hackfest and those design sessions, this reference architecture was created. So all of the input that we gather from the field and from the customers was distilled through this event to come up with best practices and identify gaps, and then produce this final document. So yes, I am the author of the document, but really my job was to kind of engage, filter, and distill all of the learning from our field and customers. So I know that this is an OpenShift Commons briefing. For those of you that don't know, OpenStack is our on-prem private cloud offering. I'll talk a bit more about it later, but just some important things to know for the context of this talk is that OpenStack has two clouds. There's one cloud, the undercloud or the director node. That's a fully fledged OpenStack deployment on a single node that is used to configure and deploy the overcloud, which is the cloud where customers run their workloads. And the overcloud is made of controller nodes that run the API endpoints and services. They're somewhat analogous to master nodes in OpenShift, compute nodes that are similar to worker nodes, and then storage nodes. This reference architecture, we actually use Ceph, which is our software-defined storage that's very tightly integrated with OpenStack as the storage backend for OpenShift. So the relationship, this is just an overview of the architecture, and it shows the relationship between the two products and how they're layered together. So what's important to understand is that the relationship between OpenStack and OpenShift is complementary. These are not alternative approaches to do the same thing. OpenShift consumes the resources that OpenStack produces, and you can see some of those things here. So OpenStack can provide you with virtual machines or bare metal nodes. It can manage bare metal nodes that you can actually run your containerized applications on. And then the OpenStack APIs for storage, Cinder for block storage and file storage, and then Swift for object storage, are consumed by OpenShift as persistent volumes through a storage class or multiple storage classes. And also we use Swift, which is the object store for OpenShift's internal registry. And then on the networking side, OpenStack has very robust support for self-service networking, and it supports many plugins from different vendors such as Cisco. The Neutron networking piece on OpenStack provides load balancing as a service through Octavia. This can be used for the OpenShift routers, and when you expose a service, load balancer for an exposed service, and also Courier, which is an integration that allows OpenShift, instead of OVS multi-tenancy or network policy, to use OpenStack networking verbs directly, so that your OpenShift pods are directly connected to your OpenStack software-defined networks. So the important thing to know from this slide is that the relationship between the two products is complementary, and they're co-engineered so as to be very tightly integrated. So why, I just throw this slide in there in case there are people that don't understand why you might want to run these things together. So first of all, you would run OpenShift on OpenStack if you have a need for both virtual machines and containers on programmable infrastructure. So if you just need containers and you don't need virtual machines, maybe this doesn't make sense, or vice versa. But if you need both, this is a great way to do it. Also, you get scale and automation at both layers. So perhaps, this is programmable infrastructure. It might be different than other virtualization providers in that it's very programmable and automatable, if that's a word. A third reason is to give your developers a consistent public cloud-like experience. So if you are accustomed to running OpenShift in, say, Amazon or some other public cloud, and then you want to bring some of that capability on-prem, if you slap it on a virtualization platform, you might not have all of the self-service capabilities that you're accustomed to having in the public cloud, like DNS, self-service networking, self-service storage, etc. And then the last reason is that OpenStack has native multi-tenancy. Many organizations can share the same OpenStack deployment, which reduces the administration overhead, but their resources are sequestered from one another. This is what we're seeing more and more from customers. Each organization wants to spin up their own Kubernetes, their own OpenShift, and own it and run it. They don't want a massive Kubernetes that's shared, that scales out horizontally. So OpenStack is a great match for that deployment model if you want to run many Kubernetes on the same infrastructure. So now a bit about the architecture. I mentioned that you can run OpenShift on bare metal through OpenStack. However, in this reference architecture, we're running OpenShift in virtual machines on the OpenStack hypervisors. And you can see how that's kind of laid out in this diagram. So the reason that we chose virtual machines and not bare metal nodes is that is what most of our customers are doing. So that is the more common case. So that is the one that we thought that we would describe. Now, in this reference architecture, OpenShift is deployed in a single OpenStack tenant, although you can deploy multiple OpenShifts in a single tenant or deploy multiple OpenShifts in different tenants. But in the reference architecture, they're one tenant, and I call it the shift stack tenant, which you see on the right. It's surrounded by the blue box. Now, the OpenStack compute nodes are the actual hypervisors where the virtual machines run. And the native OpenStack scheduler will load balance the roles of the different OpenShift machine types across the hypervisors by default, although there are also ways to enforce that anti-affinity if it doesn't happen by default. But to give you a further layer of separation, we do support deploying the nodes into availability zones. And usually the availability zones in the OpenStack context will be separate racks with separate power sources. So I guess that's really it. This reference architecture is targeted for existing OSP customers who want to add OpenShift capability to their deployment. And it's really best for the customers that have about, say, 70% or more virtual machines, and they just want to add some container capability to that. And it's really targeted at a medium to small scale for an OpenStack deployment. So if you have an OpenStack deployment of, say, 20 to 64 compute nodes, this would be appropriate for you. If you're going above that, then this architecture is not suitable. There are other things we would have to do. Now, internally, Red Hat's whole CI/CD system runs on OpenShift on OpenStack, and we have hundreds of compute nodes. So we do have a lot of institutional expertise about deploying these things together at a large scale. But because it's not, we chose to focus on the common case, which is kind of this small to medium 75% virtual machine workload case. The last thing I'll mention is that I already mentioned this, but we rely on Ceph heavily in this reference architecture. So we expect you to have Ceph as the storage backend. So drilling down a bit further into the architecture, this diagram maps the OpenShift services to the OpenShift node roles and the networks that we deploy. So the first, we're going to start kind of on the right with that light blue network that says public network FIP. So that stands for a floating IP. The only endpoints that are publicly accessible in this reference architecture are the API load balancer that load balances the OpenShift API endpoints across the master node, the router load balancer that you can use to access the other services that need to be externally accessible or exposed applications, and then the deployment host. The deployment host is at the bottom. So we use a deployment host. We also call it a bastion host or a jump host. That node can be connected to publicly via a floating IP address provided by OpenStack. We don't put floating IP addresses on the master infrastructure or application nodes. That can be done, but we don't recommend it because that exposes your internal OpenShift platform to the outside world and other tenants. So with the deployment host, those things get a bit of separation and additional security. Moving left, we have a deployment network. This is kind of the service and management network. This is a software-defined network in OpenStack that is used to actually deploy the OpenShift virtual machines and manage them. Moving further left, we have the service network. This is very typical for OpenShift in that the OpenShift services communicate with one another via this network. And last, we have a pod network for inter-pod communication that spans the application nodes and infrastructure nodes. The services, we do have etcd on the master nodes. etcd is the state database for OpenShift. It is possible to break off etcd into separate nodes, but that is not the common case at this scale, although it can be done and is recommended at a very large scale. In fact, you could run an entire separate OpenShift for etcd at a very large scale. And then we have infrastructure nodes. This is something that's particular to OpenShift 3, but many of the services that are used to manage OpenShift itself, such as the internal registry, logging, and metric servers, those run in the infrastructure nodes. And that way the application nodes can be dedicated to your application workloads. The last thing you'll see here is Courier. Courier actually runs as pods in OpenShift to provide the networking translation from the Courier network CNI to OpenStack Neutron's SDN, and I'll talk a bit more about that later as well. But this is kind of the layout that the reference architecture recommends for the node to service to network mappings. So really that's it about the architecture itself. I mentioned the key components. I'm going to drill down a little bit into the integrations. I understand I'm moving very quickly, but I want to spend a bit more time on the integrations because that's where a lot of the engineering work was done. So one thing that's important to know is that OpenShift and OpenStack were co-engineered. The engineers worked together and tried to line up timelines as much as is possible when you're dealing with many upstream projects to ensure that we could deliver the capabilities that OpenShift required in a timeline that also worked for OpenStack's release cadence. So customers have been running OpenShift on OpenStack for a long time. But with 3.11 and 13, I would say this is the first time that we really sought to align and coordinate the schedules to make sure that the features were delivered together. The integration features themselves fall into three buckets. One are related to the instance deployment and scale, and the second are related to storage, and the third are related to networking. So those three buckets are kind of the three core capabilities of any cloud platform, and it's also true in this case. That's where we focused our integrations. So I'll mention them briefly here, but the first one I'll talk about is the installer. So we have an Ansible-based installer that I'll drill down into a little bit, but you use the same installer to both configure the OpenStack tenant and set up the networkings and all of the volumes and everything that OpenShift needs to run, and also to deploy the OpenShift nodes and configure their integrations. So that installer is really the first integration point. The second is with storage. I mentioned that we rely on Ceph heavily. We use Ceph RBD in this reference architecture and Ceph RGW to provide block and object storage for persistent volume storage classes and the internal registry. And we do recommend that you use object storage for the internal registry, even though it is possible to use a volume, because a volume kind of represents a single point of failure and does not scale as well as using RGW with an object store. What's conspicuously absent here is that we do not have Manila. Manila provides file as a service for OpenStack, which would give you your RWX storage class. At the time that this was written, there was no support for RWX storage class delivered by Ceph, so it is not in the reference architecture. And that will be coming in the OpenShift 4 reference architecture. I know people ask about that, which is why I mention it now. Last is the network. Octavia is load balancer as a service. It works kind of as a VNF. This is a little different than what you get in a public cloud where the ingress rules are programmed directly into their traffic flows. With Octavia, what happens is that when you expose a route, a VNF or a virtual machine running HA proxy is actually created that fronts the pods that are being load balanced across. So basically for every service that you exposed, you get another virtual machine that acts as a load balancer, which is one of the reasons that we recommend that kind of 70% virtual machine to pod ratio. If you're deploying many, many pods and exposing them, that means you're also deploying many, many virtual machines to load balance them, and that consumes a lot of memory. And last, we have Courier, which is the plugin for the OpenShift SDN that lets OpenShift consume neutron networking directly. So quick time check. Okay, good. So drilling down a bit into OpenShift Ansible, this is the deployment deployment tooling. It's divided into two playbooks. There's a provision.yaml playbook that is used to configure the OpenStack resources, and you run it first, and it has a separate Ansible vars file for specifying how you want the OpenStack resources deployed. And you follow that with an install.yaml, which has also a separate vars file. That one's called osev3.yaml. That's used to specify how you want the OpenShift cluster deployed. Now, the reference architecture prescribes the use of OpenShift Ansible. We do have customers that try to follow the documentation directly. They deploy manually, maybe editing files by hand and putting packages out. That is not something that we think is reproducible. So if in order to follow this reference architecture, you need to deploy via OpenShift Ansible. It limits us somewhat because OpenShift Ansible can't do all of the things that you can do when an expert kind of hand tools OpenShift on top of OpenStack. But to make it testable, repeatable, and ultimately more stable, we recommend the use of OpenShift Ansible. So a bit about the integration. The provision.yaml playbook actually uses the Ansible Cloud module for OpenStack to make native calls to Heat. Now, Heat is OpenStack's templating service. It's very robust and extensible. It's similar in some ways to maybe a Kubernetes deployment or an OpenShift deployment config, in that you can specify the end state of the template that you want deployed, and then it will go and enact it through an API. So the integration is that we're not, using shell and module commands through Ansible to do these things. We're actually making native API calls to Heat. So once the resources are deployed on top of OpenStack, you can actually manage them with Heat the same way you would manage any other resources deployed by Heat. So Heat will deploy the compute nodes, so your virtual machines for your master infrastructure and application nodes. And if you can also use heat to deploy, say you wanted to run your application nodes on bare metal, the OpenStack Ironic service can manage a pool of bare metal servers, and you can use heat to deploy to those as well. That is not in the reference architecture. However, we do have customers doing it. There is a use case for running your master nodes and virtual machines on, your master nodes and infrastructure nodes on virtual machines so that they're more scalable. Say you wanted to add routers or something like that, or protect them and back them up with the way that you protect all of your other virtual machines, but then you want the bare metal performance of deploying your compute nodes directly onto physical servers. There is a way to do that, but again, that is not the common case, so it is not in this reference architecture. So the storage networking, we have an OpenShift Cinder provisioner that basically watches the API, OpenShift API endpoint to intercept events related to creating, updating, deleting a storage device. So this kind of depicts the workflow. If a pod on an OpenShift node needs a persistent volume and you make a persistent volume claim, the Cinder provisioner will see that request, and it will actually make API calls directly to Cinder to create the virtual disk, the block device, and then it will make calls to Nova, which is the OpenStack API for managing the servers, and instruct Nova to attach the Cinder volume to the Nova compute node that has the pod on it. So it does all of that translation and fulfill the persistent volume claim. And then that Cinder volume appears on the host as just a regular SCSI block device. So we've had this feature for a while. I think we had this in 3.10 and earlier versions of OpenStack. But this model of having a kind of a pod that listens to the API server, intercepts, and then interacts directly with the OpenStack APIs, this pattern is repeated for most of the integrations. I'm only going to go into one more, but this is kind of the pattern that we use to integrate. So for Courier SDN, quite a lot of work was done to allow OpenShift pods to access OpenStack Neutron networks directly. That is because both OpenStack and OpenShift use encapsulated networks in order to communicate. So what would happen is that if you're, say, for example, your layer 2 communication is encapsulated on the OpenStack layer, and then you're using OpenShift multi-tenant SDN on top of that, the packets get encapsulated twice, which can introduce some performance overhead and some complexity for troubleshooting. So the decision was made that if the OpenStack SDN is already in place, to let the OpenShift pods directly into that, plug into that in order to reduce the complexity and improve performance. So the way that works is that every OpenShift node runs a pod called the Courier CNI pod, and the Courier CNI pod is responsible for interacting with Neutron. The Courier CNI pod will then make the request the resources from the OpenShift API server, which is being watched by Courier controller, and the Courier controller pod actually runs on the infrastructure node. When the Courier controller pod sees the request for OpenStack network devices, it will first make a call to Neutron to create a virtual interface for the pod that's plugged into the software-defined Neutron network. And then it will also create a load balancer entry for that address and port on the pod if it's exposed. The Neutron agent running on the OpenStack compute node receives the request to plug in the virtual interface and attaches it to an Open vSwitch integration bridge that's running on the application node, and then gives the interface directly to the pod. So this is the same pattern that we've seen on the Cinder side, but repeated for Courier. Doing this another way would kind of be an anti-pattern. We have pods that running in OpenShift that control the interactions between OpenShift and OpenStack. One thing I will point out about this is that although there's a Courier CNI pod that's running on every node. In this reference architecture, and it's mentioned, there's only one courier controller pod. So if anything happens to the infrastructure node that's running the courier controller pod, the networks should be fine, but new requests will be queued until the courier pod is respawned on a different application node. And we do have some of the network engineers, I believe, on this call. So if I said anything wrong there, please correct me during the QA portion. But I believe all that to be correct. And recently, Ramona Sato, who's the product manager for OpenShift on OpenStack, published a blog post along with Cy Melaner, I'm not sure I'm saying his last name right, describing some work they did to characterize the performance uplift that you get with Courier over using kind of the double encapsulated OVS ML2 with OpenShift SDN on top of it. And you can see on the left, you can see a stream, which is kind of a bandwidth test, that on small packet sizes, the performance between OpenShift SDN and Courier is very similar. But as the packet size grows, you see massive increases in performance. So if you have something that is very bandwidth sensitive, an application that requires you to transfer a lot of data in large chunks, Courier can give you a tremendous performance uplift. On the right, we have it's more of a latency performance comparison. Now the metric for this, it's I believe transactions per second. I don't have that in the on the y-axis there, but higher is better. So lower latency means it takes less time to send the packet. So the more that you can do in a second, the better. And you can also see that Courier gives you a performance uplift across all packet sizes when you're in terms of latency. And for most of the OpenShift workloads that don't involve, say, for example, OCS, they are more latency sensitive than they are bandwidth sensitive. So across every packet size, you should see a performance uplift when you're using Courier. And I recommend to everyone to go, if you're interested in Courier, go ahead and read that blog post, because there were many, many other tests that they ran, but I couldn't distill them all into one slide. So just a little bit about future work. Now with OpenShift 4, there are kind of two classes of installation. One is installer provisioned infrastructure, which means that we don't really allow a lot of choices in how it's deployed. So you upload an SSH key, you pick the provider that you want to deploy to, and basically we push out OpenShift in one way. Now, right now, OpenShift 4.1 is the current release, but the IPI installer for OpenStack is OpenStack 13 is coming in OpenShift 4.2. We also have a deployment model called user provision infrastructure, which is a lot more customizable. The customer brings their own infrastructure and then just deploys OpenShift on top of it, instead of having us make the decisions of how the infrastructure should be deployed. That is coming in OpenShift 4.3, which is coming later. I don't know if I'm allowed to give exact dates, so we'll just say that's coming later. But the main thing to know is that Red Hat's been kind of it's been suggested to us in the past that we need to be more prescriptive with how we recommend we deploy this stuff. Well, the OpenShift IPI installation is just that. It is full stack automation that is very prescriptive and deploys OpenShift on and configures OpenStack exactly how we recommend it. But we also want to reserve the capability to give customers choice. Say they have a disconnected environment, or they have a specific, I'm just making stuff up, a storage backend they have to use. Then we still offer the flexibility with UPI to kind of customize the deployment how you want. So concluding, this is a bit of a roadmap on what's coming. So you can see in 3.11, all of the things that I talked about are features that we delivered, such as integrating Octavia load balancing, OpenShift Ansible deployment, internal registry on Ceph RGW, and namespace isolation support with Courier. In OpenShift 4.1, there really was not a lot of work done in terms of OpenShift OpenStack integration that focused on some other providers. But in OpenShift 4.2, and all of this is public if you're following the upstream code changes, but remember, all of this is subject to change because it's the future, so this is not a guarantee, but just letting you know what we're working on is the IPI installer that I mentioned, and also Courier support for network policies and IP blocks, which will basically give Courier richer support for making decisions to kind of arbitrarily connect pods across namespaces. So that was about 28 minutes. And I apologize if I spoke too quickly, but now I can pause for questions.
Yeah, I think this was great. Definitely don't want to add anything more. Just, yeah. One thing I'd add in here is, so the key goal here is to simplify your deployment experience. So that way, like, you don't spend a lot of time with setting up the solution, and you can spend more time on the day two operations in terms of like having your developers and the solutions architect start provisioning VMs and containers, say, for the applications use. So that's why the goal with this is to de-risk deployments by giving you prescriptive guidance.
So there is one question from Jose asking, is Courier supported from OpenShift 3.11 side, or is it a technology preview?
It's supported.
So if anyone else has any questions, now is the time. Otherwise, we will make sure that everybody's contact information is alongside the email. Here comes one. Steve M is asking, you mentioned Manila earlier, and he's wondering if he missed that in the roadmap.
Yes, I don't know if that's in the roadmap slide or not, but so Manila support can be delivered a few different ways. So
Can you refresh my memory? What is Manila? Since
yes.
I'm not a diehard OpenStacker.
Yep. So Manila is file share as a service. That's not me. It's kind of a similar to Gluster in some ways. It allows users to create to request shares that are similar to NFS shares that are mounted over the network. And Manila, the capability is something we've had in OpenStack with Ceph for a while. You can consume it either via the CephFS client or via regular NFS clients. That feature is called Ganesha. Manila is being implemented with Rook, Rook being the operator that can be used to provision storage in OpenShift, and there's a Ceph backend plugin for Rook that can provide Manila shares and also block shares. So the state of Manila right now is that, there's kind of two pieces to it. If you have Ceph deployed in OpenStack and you have Manila configured, work is being done to certify Manila and consume Manila shares from OpenShift natively. But there is also work being done for the Manila CSI provisioner to allow you to consume Manila shares through that are deployed by Rook. I believe that Manila, the support for the CSI part will be added in OpenShift 4.3, which is when we're also supposed to have OCS. But I can't, I'm not positive of that, so don't hold me to that. But work is being done right now to test and validate Manila, the kind of the first case, which is native Manila delivered by Ceph with OpenShift 4.2. However, I don't know if it will make it for the 4.2 release. So that was a very long answer, but there are a lot of pieces involved to getting the Manila support in. I should add a bullet for it though here. That was a good suggestion.
Jose is also asking about what about OVN support?
So OVN, so Courier is somewhat agnostic to what is behind it. There are a lot of performance numbers that were gathered running Courier over OVN. OVN is another OpenStack network encapsulation backend plugin for Neutron. Right now we use OVS, but OVN is going to become the new thing around OpenStack 15 or 16. It's supported in OpenStack 13, but not the default. Right now, Courier does work with OVN. We did not put it in the reference architecture because there is not a lot of kind of mileage behind it. There are not a lot of customers yet using it in the field. There's also the piece with Octavia, which also needs some further testing and examination. So the OVN with Courier is something that works. But it is not something that for the reference architecture, again, we wanted to go with the common case. So because OVS ML2 is the common case for most of our deployments, that's what we're using with Courier.
All right, well, that looks like all of the time that we have today, and I think you've answered all the questions. I'm sure there'll be a few more. I will post this video up on our YouTube channel, and I will have Jacob back and Abhinav as well, talk more about this subject in a not too distant future. So thank you very much for your time today, Jacob, and for everybody for attending. Obviously, it's a popular topic, so we're looking forward to doing more, and hopefully we'll be seeing a lot more of OpenShift on OpenStack and OpenStack content in future OpenShift Commons gatherings as well. So if you're coming to Red Hat Summit in 2020, we're planning on having a sidetrack on OpenStack at the Commons event. So make sure you watch for those announcements. If you have a use case or you're someone who's got an OpenStack deployment, we'd love to give you the podium either as a briefing or a gathering. So please do reach out. We're very much open to having you share your best practices and lessons learned. So thanks again, everybody, for coming. And look forward to hearing more from all of you. Thanks, Jacob.
Thank you so much.